Okay, today we are going to talk about another important concept of electricity. In our previous video, we had discussed about electric charges and we had seen that electric charges are a property of matter due to which there are forces of attraction or repulsion between two objects that have these electric charges. We had seen that like charges they repel and unlike charges they attract. Today we are going to talk about electric current. So without wasting any further time, let us straight away dive into today's topic, that is the topic of electric current. Now, the definition of electric current is as follows. Electric current is defined as the rate of flow of electric charge. Now let us try to understand this in some greater details. Suppose we have a wire like this, and through this wire, say in a time of 5 seconds, some number of charges are flowing through it. Suppose this is one charge, this is another charge, this is the third one, and the fourth one. Okay. Now let us assume, for the sake of simplicity, that all these charges have the same magnitude, each having 1 coulomb contained in it. So all these charges are of 1 coulomb each. So in total, we find that 4 coulombs of charge are flowing through this wire in the given time. And what is the given time? The given time is 5 seconds. So this is 5 seconds. So let me put down that second. Okay, so 5 seconds, 4 coulomb charges are flowing. Now let us take another example. Suppose we have a similar kind of wire, but in this wire now, again in the same time interval of 5 seconds, some number of charges are flowing. However, in this case, the number of charges flowing is not the same as it was in the earlier situation. This time we have more number of charges flowing through the wire in this given time. So suppose each of these charges have magnitude equal to 1 coulomb, then we have a total of 1, 2, 3, 4, 5, 6, 7, 8 coulombs of charge flowing through the wire in the same amount of time, that is 5 seconds. So we say that the current, electric current flowing through the second wire, let us name the second wire B, and let us name the first wire A. We say that the electric current flowing through the second wire is more than the electric current flowing through the first wire, because the number of charges flowing through the second wire, that is wire B, per unit time, that is per second, is greater than the number of charges flowing through the wire A in 1 second. So let's calculate how much charges are flowing through each of these two wires in 1 second. Here we have 4 coulomb charges flowing through the wire in 5 seconds. So we have 4 divided by 5, and that gives us 0.8. So we have 0.8 coulombs flowing in 1 second. On the other hand, here we have 8 by 5, and that is equal to 1.6. So here we have 1.6 coulomb flowing in 1 second. So we can see that here the charges flowing in 1 second is less than here, where the charges flowing in 1 second is more. So we say that the electric current through this wire is having a greater value or greater magnitude compared to the electric current flowing through this wire. How do we calculate electric current? You might have already guessed it. We calculate electric current in the following manner. Electric current, denoted by the capital letter I, is the rate of flow of electric charge. So in the numerator we will put electric charge, and in the denominator we will put time. So electric current will be equal to the amount of charge flowing per unit time, just as we have seen in these examples. So in this example, we see that the electric current is charge per time, that is 0.8 coulombs per second, and here it is 1.6 coulombs per second. We have a special unit, special name for the SI unit of electric current. So the SI unit of electric current is ampere. It is abbreviated as uppercase A. So in both these cases, in this case, the current, electric current flowing through this wire is 0.8 ampere. We'll just write it down. It is 0.8 ampere, so A, and in this case also it is 1.6 ampere. So that is a brief discussion about what electric current is. We'll take a break and come back for more such discussions. Thank you.